All right, hey, this is the remediation video for polynomials. So I'm just gonna work out these problems. We're gonna work on do some practice here, and then we'll try a little assessment on it. Let's see. First question here, just multiplying. That's multiplying two binomials. Some people say FOIL, first, outer, inner, last, but it's kind of a better approach to think just distributing. Distribute that one. Distribute that one. Or for some of you, you might like the area model. So I'm gonna draw that out with this example. Let's see, 2x. 5, 3x, -1. Doesn't really matter where you put them because all of them are being multiplied by the others. So this would be like 2x times 3x is 6x squared. This would be -2x. That's 2x times -1. This would be 5 times -1, which is -5. 3x times 5 gives you 15x. Then you just kind of collect all the things in here and combine any like terms. So these two are both x's, so we can combine those. 6x squared, combine these two, that gives us plus 13x minus 5. All right. Let's keep going on here. Okay, so a lot of these you might need your exponent rules. Exponent rules, but also using what we just did with the area model or foiling or distributing. So a 2, that means a square. So that technically means x minus 4 times x minus 4. And all of a sudden, it's the same problem as we had up here now. It's just multiplying two things. So that would be, now this time I won't do the area model. I'll just do it by distributing. X times x is x squared. X times negative, it's -4x. -4 times x, another -4x. -4 times -4, that's a plus 16. Combine your like terms. Plus 16. There you go. All right, now again, I know I'm going kind of quickly, but remember this is a video. You can pause, rewind, stop, whatever you need to at any point. So please keep that in mind that you can do that. All right, next question here. Add. This is a little annoying. These parentheses don't mean anything since we're just adding. So you could get rid of them if you wanted to, if they're getting kind of in your way. And you're just combining like terms. That's all you do with polynomials. So let's see, a 5x cubed and a 2x cubed. That's 7x cubed. And this is what I like to do when I have added something. I get it out of the way so I don't see it. X squares, I only have this one. Plus 6x squared. Get rid of it. X's, I got -3 and -1. That makes -4x's. Get rid of that. And what's left? 7. That's it. Moving on. Subtract. Okay, now these are a little annoying. See, the one up here, let me erase that real quick. Because you were adding, the parentheses didn't mean anything. You combine like terms. But with a subtraction, that means you need to distribute that negative first. Or you could look at it like flipping the signs of all of the rest of all of these terms and then combining. So really you've got here is 9x squared plus 3x minus 4 minus 3x squared minus 8x minus 1, except negative times negative is positive, so it'd be plus 1. So again, we basically flipped all the signs that were in here. This became a negative, this became a negative, this became a positive. But it's up to you how you want to view it. So I'm going to scratch that out now. And now I'm just combining like terms like we did in the last problem. 9x squared, get rid of that, mess me up. 9x squared minus 3x squared is 6x squared. And I'll get rid of those now. 3x minus 8x, that's -5x. That was weird. -4 plus 1, -3. Okay. Real quick. Check here. Yeah, the way I like to do these, I don't like to write all that out. So I'm going to check it real quick here. 9x squared, and then I just say minus a 3x squared, 6x squared. 3x minus 8x. Sorry, yeah, 3x minus 8x is -5x. And then -4 minus -1, which is the same as -4 plus 1, gives you -3. Good deal. Oh, factoring, okay. I'm sure you've seen a lot of YouTube videos or videos we've posted on Box and Diamond. I encourage you to go check those out. I'm going to start with this one over here. I'm going to do 34 first, actually, and do a full Box and Diamond. But you should be able to go look up any of those examples we've done in Box and Diamond. There's a lot of them out there. There are a lot of them out there. Let's see. Multiply the first and third terms to go here. -28x squared. Middle term goes here. And then we can put those over here now. Let's see. X squared goes here. So usually you should do that first, really. Say the first term goes here, third term goes here, and then multiply them to go at the top. and then the middle term goes to the bottom. All right, let's see. Two numbers that multiply to be the top and add to be the bottom. So you could list out the factors of 28, and all of these will be plus or minus, since it could be plus or minus. So it could be 128. You don't know which one's positive or negative. So some people just like to write that down. It could be like that. You don't know. 128 could be 2 and 14. Let's see, 3, no. 4 and 7 could be it. 5, no. 6, no. So it's all plus or minus these numbers here. Then you ask yourself, well, which ones of these, which combo of these could give us a negative 3? These two could not combine to give you 3. You could be like 29, 27, that's about it. These two, they could give you like a 12, they could give you a 16. Definitely not going to be a 3. But then you ask yourself, how could 7 and 4 somehow combine to give you negative 3? Well, if you had a negative 7 and a positive 4x. So let's check it. These two multiply to be negative 28, x squared, and they add to be negative 3x. So that's good. So those are the ones we want. So 4x here, negative 7x here. Okay, now let's ask ourselves, what do these two things have in common? They both have a 4, and that's it. What do these two have in common? An x. What do these two have in common? An x. And now I can check myself. 4 times x is 4x. So that's good. And then you could go about this a couple ways, but you could look at it like x times what is negative 7x? Well, it's negative 7. 4 times negative 7 is negative 28. Good deal. So our factored answer is x plus 4 and x minus 7. Okay, so you take those and you put them right here. Just like that. Cool. Now let's try this one. This one's a little different. We could do box diamond with it. So, or you could, yeah, let's do box diamond with it first. These are a little bit simpler because there's only 2 terms. So let's see what happens. So 4x squared goes here. Negative 1 goes here. Multiply those two to go up here. Negative 4x squared. Middle term, the middle term, there isn't one. There isn't a middle term. There's only 2 terms. So that means it's a 0. 0x. Let's see, they multiply to be the top, they add to be the bottom. Well, since they add to be 0, they have to be the same number. So you basically take the square root of that, but it has to be the same number. So it's negative 2x and 2x. They combine to be 0, and they multiply to be negative 4. Put this in over here. 2x, sorry, negative 2x and 2x. So these two have a negative 1 in common. These two have a 2x in common. These two have a 2x in common. And these two have a 1 in common. So that gives us our answer, 2x plus 1, 2x minus 1. You might also pick up the pattern of difference of squares. That's what we have here. When you have 2 numbers that are being squared and there's a subtraction, then you get a difference of squares. And that's the square root of the first plus or minus the square root of the second. Oh, okay. Simplify. Oh, wait, sorry. So let's go back up to this. Order here. All right, let's go to 30. What is the greatest common factor of the expression below? There's a lot going on here. Let's look at just the integers and ignore the rest of that for now. 24, 18, and 12. Definitely a 6 in common there. They all have a 6 in common, so we can get rid of those. They all have a 6. And let me get a little room there. So 6 times 4 is 24. Minus 3 will give 18. And plus 2. Now I left all the space in there for all the variables. We'll get to that next. Okay, now what do all the variables have in common? Look at A's. Let's look at just A's. There are 6, 3, and 2. So they all have at least 2. So you pull that out. That leaves you with 4 in the first one. Leaves you with 1 on the second. And no A's in the last one. Okay, so I've taken care of that and that. That and that. And that. Just look at the B's now. How many in common? 2, 1, 3. So I'll have at least 1 in common. So pull 1 B out. That leaves no B's in this middle one. There's 1 B right here. And then 2 in the last. So when it says for the greatest common factor, it's this right here. That's what I factored out. If you think about like undistributing. Let's see. I'm going to rewrite this. Where we use that method of rewriting. I'm going to rewrite this so it looks a little bit more like what we're used to. 4mqp divided by 2m to the third p. All right, let's just check it out here. 18, 36, 4, and 2. If you divided all of them by 2, you'd get 9. Let's see, 36 by 2, that's 18. Put a plus 18 minus 2. Okay, let's get rid of those. Okay, look at M's. Got 5, 7, 3, all divided by 3. So 5. Now this is your exponent rules. 5 minus 3, or think about 1, 2, 3, 4, 5 over 1, 2, 3. 1, 2, 3 of them cancel, leaving you with 2. That's the same as 5 minus 3. So you could either think about subtracting them or writing them out this way and canceling. 5 minus 3, that leaves you with 2 M's. 7 over 3, that leaves you with 4 M's. 3 over 3, that's 1, so the M's cancel out on those. No M's. The last one. Okay, P's. We got 1 on the bottom here. We got 4 up top here. That leaves me with 3. P3 over P, that leaves you with 2. And same thing here. P over P is just 1, so you're left with no P's. And that's our answer right there. That's not very clear. I'm sure that the P is down here. There we go. Okay, what is equivalent to this? Oh, this is just multiplying. So let's see, 3 times 2 is 6. X to the 2 times x to the 4. You are adding exponents. If you get your exponent rules, you'll see that you're adding when you multiply two things. You add the exponents. So that is our answer right there. Here's another exponent rule problem. You are going to, when you have a 3 here, you don't add, you distribute, as in you multiply. So this becomes 6, 12, 18. And this becomes h to the 9. Okay, that's the rule that's happening there. Look at your exponent rules. Let's do this one now. Okay, this one's a little tougher. 252. So, couple ways to look at this. The way that I know I like to talk about is I need to find a perfect square that evenly divides 252. So a number like 1, 4, 9, 16, 25, 36, 49, 8 is 64, oops, 81, 100. Let's see, does it evenly divide any of those numbers? I'm going to try 16. Does that work? No. Okay, 4 works. And is there a bigger, you want the biggest number that'll divide it though. So I'm going to try a couple here. No. No. Let's see, no one may work. This one. No. What about this one? No. All right, so I'm just typing around here and I don't really see those. Let's just use 4 for now and see what happens. Because, oh, no, I found another one. 9. Looks like 9 works. All right, so let's just try 9. So square root of 252 is the same thing as the square root of 9 times the square root of 28. So let's see what happens here. 28. Well, square root of 9, that's just 3 times square root of 28. So ask ourselves, 28, can that be divided by any of these numbers up here? Yes, it can. It can be divided by 4. So that means this becomes 3 times the square root of 28. Well, that's 4 times 7. Okay, but that's also the same thing as, 3 times the square root of 4 times the square root of 7. But what's the square root of 4? It's 2. So 3 times 2 times square root of 7. So that's 6 square root of 7. Ask yourself, can you break 7 down anymore with any of these numbers up here? No, you cannot. And that's our final answer. Okay, so that's the simplification of this. If you want a little trick, go to your calculator, type this in, and type your answer in, and see if they're the same. They should be the same decimal, that is. All right, last one, simplify. 15 divided by 3, 5. 7 m's over 1 7, that's, 7 m's over 1 m, that leaves you with 6. And again, think about 1, 2, 3, 4, 5, 6, 7. There's 7 of those on top, 1 on the bottom. One of these make a 1. And we talked about how you make a 1. M divided by m is 1. Leaves you with 6 m's. 6 c's over 2 c's. Using that pattern, that's just going to be 4 c's. There's the answer there. So again, I know I go quickly. Please feel free to go back, slow down, rewatch anything that you didn't quite get the first time.